Welcome, everyone. This is Erma Anderson, and I'm apologizing for not being there in person. But what happened was that I really made a big mistake in my scheduling with the GMT time, and I double booked myself. So I promise you that in the next session, I will be live and I am available to answer any of your questions. So what happens is that you will see my email is on my first screen, and I would like you, if there are questions, would you please just send them to me or we will answer them the next time. So I'm looking forward to working with you over the next 4 sessions. We are going to take a journey of looking at what the National Council of Teachers of Mathematics asked us to do last March, April, and May, when we learned that there was going to be an interruption in learning. So in these 4 sessions, we're going to take a look at that. How do we plan that learning journey as suggested by the National Council of Teachers of Mathematics, as well as many other organizations, including the United Nations, UNESCO, the Office of Economic Cooperation and Development. And then the second session, we're going to take a look at what kinds of tasks do we offer our students to do? What is it that we're asking them? How does it support the learning that we are expecting? Session 3, we're going to look at a very critical aspect of mathematics, and that is the mathematical discussions, that facilitating that meaningful discussion. What are the questions that we ask to keep those conversations going? And then in the 4th session, we're going to look at, do we have evidence that students are learning? So as we take a look at these 4 sessions, we're really basing it on the National Councils of Teachers of Mathematics of moving mathematics teaching forward. And how do we support it? The key recommendations were determine the essential learning of your grade level and spend the majority of your instructional time focused on those critical areas. The second thing was determine the necessary prior knowledge to determine what students might be missing or what was taught previously and they didn't quite get it. And then to strategize how we're going to support that just-in-time learning so that all students are at grade level in our learning. The third thing was, what do students know? Lots and lots of formative assessment to advise learning as well as advise instruction. How do we do that? Let's use rich mathematical tasks instead of the typical pre-testing and post-testing that we do. And finally, the last one, which will be a focus in all 4 of these sessions, how do we support teachers in learning and using effective mathematics teaching practices so they can provide that high quality instruction regardless of the situation, whether it be online, face-to-face, hybrid, whatever the method, good teaching is good teaching. What does that look like? So those are the 4 sessions. So in this very first session, we're going to focus on identifying the learning intentions of the priority content and what is the prerequisite skills. But then we're going to take a look at what does the journey look like? What is the learning progression, the map that leads to successful completion of the learning target? So that's the journey that we're going to take today. But in order to do that, we have to have a good idea of what mathematics standards look like. And mathematics standards are based on the big ideas called the domains. And if you look here, you'll notice counting and cardinality, numbers and operations at base 10, fractions, operations, algebraic thinking, geometry, measurement and data are the big ideas of mathematics at K to 5. High school, the conceptual categories are different, but we're looking at the K to 6 today, which is also includes fractions. And what are those big ideas? Then those big ideas are divided into what we call critical areas. K to 2, we focus on addition and subtraction. Primary school is all about composing and decomposing numbers. It's building the skills, understanding place value. Then we get into third, fourth, and fifth grade. The key areas are multiplication of division of whole numbers and fractions. Then we get into middle school, where it is all about proportional reasoning. So we're going to take a look today at different standards, different clusters. This happens to be from grade 3. And you notice the domain is operations and algebraic thinking. Those are clusters. Clusters are groups of similar skills. So representing and solving problems involving multiplication and division. But what are the skills that I need to do that? Multiplying and dividing within 100. What are the skills that I need to do that? So under those clusters, which are listed as priority, green, yellow is additional, and blue is supporting. So it's from here that we get the big ideas of our discipline. So if I take a look at grade 3 here, domain, big idea, operations and algebraic thinking. The cluster, can I represent and solve problems involving multiplication and division? Notice the standards or the skills. I've got to be able to interpret products of whole numbers. I've got to be able to interpret whole number quotients. I got to be able to solve problems in situations involving equal groups, arrays, and measurement. And I got to be able to determine the unknown number in a multiplication or division. All of these skills are needed to achieve this goal, this cluster. So domain, cluster, standard. This isn't critical when we talk about what we're going to be doing today. So if I look at grade 3, here are the 4 critical areas. And you see that under that critical area, there are clusters. Under those clusters, there are standards. There are green, priority, there are blue, supporting, and there are yellow, additional. So not only do we have content, but we have practices. These practices are the literacy part of our standards. If all I do is the content, the standards, I'm only learning arithmetic. The practices are what students do with this content. And so there are 8 of those practices, the mathematical practices. If you look at the PISA, the Performance of Student Achievement by the Office of Economic Cooperation and Development, or if you look at here in the US at our PARC, our Smarter Balance, or you look at the ACER test in Australia, there are 4 criteria for assessing math. There is content, but you have to be able to use that content to solve problems. And you have to be able to communicate or construct a viable argument of how you know your solution to the problem is correct. And we have to be able to take that information and transfer it to an authentic situation. So if we take a look at the 4 criteria for assessing math: content, problem solving, communicating reasoning, and modeling, the math practices are embedded in these criteria. So as we talk today and we look at our learning progressions, keep in mind that every skill that I learn for one reason only, so that I can solve problems. So concepts and procedures. Students can explain and apply concepts, carry out procedures with precision and fluency. Remember, fluency in mathematics is, I am efficient, I am accurate, and I have flexibility with numbers. I don't have to rely on one method for solving the problem. I can compose and decompose numbers. I have that flexibility. I can solve a range of complex, well-posed problems in pure and applied mathematics using the knowledge and skills I have up here and problem-solving strategies and models. I can clearly and precisely construct a viable argument, support my reasoning, critique the learning of others through the use of the correct, that's my precision, mathematical language, and models. I can analyze complex real-world scenarios, construct, use models to interpret and solve problems. What we're getting at is really the essence of what is mathematics. If we look at the definition of mathematics versus the definition of arithmetic, arithmetic is employing the basic operations of addition, subtraction, multiplication, and division. Mathematics is a way of describing a phenomenon. What do mathematicians do? Mathematicians encounter a problem. They encounter a phenomenon. They look for patterns in what they're seeing, observing. They make a generalization and they create a model to help them solve the problem. Let's go back to what we're talking about. My number sentence is a model. My equation is a model. A number line is a model. Part, whole model. The number bonds, a graph, a chart, all are models to help me solve problems. And so when I look at the criteria for assessing mathematics, this is what mathematicians do. There is some basic knowledge and skills. I use it to solve problems, a range of problems, including authentic real-world problems, and I can construct a viable argument to support my reasoning, and I can look at what others have done. This is the literacy that we're trying to get at. To be mathematically literate, these are the things that I have to do. Knowing my times table or my addition facts does not constitute literacy in mathematics. It is here. So that is the problem that we are trying to address. So everything that I share with you today, you can find on the live binder by going to Project AERO up here at the top, and then going down to mathematics guidance for 2021. So all of our resources are here. And these resources are here as we work with schools around to make what NCTM calls the decluttering of our math curriculum. Now is the time we have an opportunity to declutter. So we are decluttering, and we're going to look at how is that process done. And I can tell you from experience, the last 5 months, that when we started in June and July, working with schools to really take a look at our curriculum, to really begin that decluttering, in the first September to January, we saw tremendous improvement in student achievement. Even though we have been online, we have been hybrid, we have been a mixture of everything, good teaching is good teaching, and it works when we can stay focused. So that's the ultimate goal. So what we're going to do is we're going to take a look at today, our first session, which is how do we determine the essential learning of my grade level? Because I need to have a focus there. How do I determine the prior knowledge? So the first question you have to answer is, do you know the critical areas of your grade level? They are not new. They have been around since 1989. For a long time, they were called the curriculum focal points, how we focus our curriculum. When the new standards came out in 2010, we called them the critical areas. When you know the critical areas, we know the prerequisites to those critical areas. So that's going to be our focus today. How do we plan this journey? How do we map it so children know where they are going? So I'm going to the live binder. And when I go into the live binder, I'm going to this orange tab called critical areas. And under the critical areas, we have the critical areas which have been determined by the research for years, every grade level and every course through high school. Kindergarten only has 2 critical areas, representing and comparing whole numbers and describing shapes in space. Grade 1 has 4, sorry about that. Grade 2 has 4. Grade 3, there's only 3. Grade 4 has 4, and grade 5 has 3. We're going to look at a grade 4, and I'm going to share with you what one of our schools did. Several of our schools have done this, but I'm sharing the work from one school of how we determined and what we did with this. So we went to the critical area of grade 4, and we noticed that in grade 4, the critical areas were developing understanding with multi-digit multiplication and dividing to find quotients involving dividends. A second area was fraction equivalence, addition and subtraction with like denominators and multiplying fractions by whole numbers. And the third was analyzing, classifying geometric figures and learning a lot of the properties. So in grade 4, they went to their scope and their sequence, and they found that one of their units does deal with fractions. And that's what we would hope, because we should be able to do a one-to-one correspondence between the critical areas and our scope and sequence of our curriculum. So looking at this critical area, there is a description. Then there are these clusters, and here are the standards. They put a 4th one here because they were going to do some things with data. Many schools may not have that, but that's fine. But these 3 are essential to getting to this critical area. Can they extend their understanding of fractions, equivalence, and ordering? Can they build fractions from unit fractions by extending previous understandings of operations of whole numbers? Can they understand decimal notations for fractions and compare decimal fractions? So these were really the 3 basic clusters that they were trying to achieve. So in grade 4, when they go in and they read this, it said students would be able to use models, and they could recognize, generate, and compare equivalent fractions. Different numerators, different denominators. They could factor pairs of whole numbers. They could identify prime and composite. They could add and subtract mixed numbers and compose and decompose fractions using real-world applications. And they could understand denominators of 10 and 100 and compare them. So these were what they saw in the standards or the scales. So looking at that, if I'm going to be doing a unit on fractions, what will be the goal of the unit? So noticing that in their grade 4 scope and sequence, and by the way, on the live binder, I have used the New York Engage Eureka Math scope and sequence, but it is very similar to Match Fish Tank, very similar to Open Up Resources. So all of the new digital curriculum that you can see online, which is very good, the scope and sequences are well aligned to critical areas. If I look here, this first unit really is bringing me out of 3rd grade and what I need to be able to do to have access to grade 4. Then in grade 4 is about multiplication and division. It is about some geometry, learning, and so on. And then it's about fraction. So I can easily see those critical areas here. But going back to my unit that I'm developing, this is a unit on fractions. What will be the goal of this unit? We're all familiar with understanding by design. Number one, I have to identify the desired results. That's critical. So, what's the goal of this unit? Then I have to determine that acceptable evidence. How do I know when my students have achieved it? How will I know? And then I have to plan the journey. I like to use this analogy that I'm on the east bank of the river, and I've got to move my students across to the west bank. Across the river, there are lots and lots of stones. Which one of these stones, which we'll call the learning progressions as we're going to see, how can I move from point A to point B? How will I move from point A to point B? That is the learning journey that I have to plan. And that's where we're going to focus today. So what is the learning goal? What would be the learning goal? What prior knowledge will they have? And then how will I get to the other side? Remember, all new learning is constructed on prior learning. Critical. The more we understand about what students already know, what they're thinking, the more we can engage them in the learning that needs to occur to get to point B or the end of the lesson. So this is a template we've been using. They decided that after looking at the clusters, that this would be a good learning target. I can use my understanding of equivalent and decimal fractions to solve problems. It's not, I can understand decimal fractions, I can understand equivalent fractions, I can add and subtract equivalent fractions. Rather, why? I can use it to solve problems. And of course, that implies that if I solve this problem, I can construct a viable argument. So once we have that big idea, our next thing is, what will be our evidence? I want you to look at this problem that they selected as their evidence. There was 2 or 3 problems, but I just chose one of them. One of the things that we learned last summer in looking at the research was keep our problems simple. Dig into a child's thinking by asking brain dump questions. And I want you to take a look at these brain dump questions. Almost everybody can do this room. This picture shows Kristen's room. What part's been painted? This one shows Alex's room. What part's been painted? Kristen thinks she painted more. Do you agree? Explain your thinking. All right, I get an answer there, but I need to probe deeper. Do they really, truly understand? Let's see, how many squares are shaded? How many squares total are shaded? What decimal part represents a shaded? How do you know? What decimal represents a shaded part? How do you know? Sorry, how can you represent the same portion using fractions and decimals? How are fractions and decimals similar? What do the denominator and numerator represent in a fraction? What does the denominator? How does it affect the size of the pieces? What makes some fractions equivalent? How can fractions be represented on a number line? If you have 2 fractions, how do you know which is greater or which has more value? Now, if you stop and you think about it, the brain dump questions are how we determine what it is that children really understand. So that's going to be their evidence. After we've done that, now we need to know, do children have access to this journey? And that comes from knowing what is the prerequisite. If we go into 3rd grade, Third grade, the prerequisite says they can identify and describe equivalent fractions using the number line and visual models. So this will provide access. Actually, if I look at the standards, here's what they do in grade 3. They're introduced to fractions. They learn that a fraction is a part of a whole. They learn how to put a fraction on a number line. They compare fractions by reasoning about their size, and they use visual models and number lines. They also begin work with fraction equivalence using models and number lines. So this is the prior knowledge that is needed to have access to this new learning. So imagine this, you're on the left bank, the east bank of the river, you're headed toward the west bank. Do my students have access to this journey? That comes from the prior knowledge. So I need to assess that prior knowledge before I begin the journey. So this was how they did it. This is a simple, what we call an anchor task. I want to know, what do my students know about fractions? Eva and Sean each bought a small cheese pizza. Eva cut hers into 6 pieces and ate 2. Sean, same size, into 3 and ate 1. Eva said she ate more pizza than Sean. Sean said, no, we ate the same amount. Who was correct? How do you know? And so this will give me access to know if they're ready for the journey, because now I have to plan the journey. And this is where I think, and I know from looking at people's units in UBD, units in Atlas Rubicon, Canvas, other places that you see them, no matter how you have them documented, what we often see here is just a listing of activities, tasks, assessments. And I want you to look at this statement. A collection of tasks, activities, assessments does not entail a system any more than a pile of bricks constitutes a house. What does a journey look like as I move from 3rd grade to 4th grade? And much has been written about that, how children learn math. Our standards are a progression. They're a macro progression of going from 2nd grade to 3rd grade to 4th grade to 5th grade to 6th and so on. Those are macro progressions, which means that it's a more sophisticated way of looking at a concept. However, in going from 3rd grade to 4th grade is also a progression, a micro progression. What are those chunks of information that I need in order to get to that learning target? So as we look at this, we're planning that journey. Notice that I only have 5 of these. The literature is very clear that when I'm doing these units, I never have more than, I keep it slim. We've done some units this fall that only had 3 of these progressions, because you want to keep the focus on the chunks. Now, if you go into any of the literature on inclusion in the classrooms, on number 1, it says, chunk the material. If you go into English language learners, it talks about chunking the material. That's that learning journey that we're planning for students. What does it look like? So how do we do that? Well, how do we get from 3rd grade to 4th grade? Well, we go in, let's define the learning progression. It's a description of a successfully more sophisticated way of thinking about an idea that follow one another as students learn. It's like climbing a set of stairs or climbing a ladder. It's about going on a trip. How do you get from point A to point B to point C to point D to get to your destination? It's a description of how student learning occurs. And we have lots of studies on how different concepts are developed. What does that look like? In the book, What Are Learning Progressions? Knowing what students knows describes a lot of the concepts in math, science, social study. But mathematics standards, as were the other standards, built on progressions. As a matter of fact, on the live binder, under progressions tab, I have included the research on how number sense, counting and cardinality, algebraic thinking, how it occurs K to 5, how does it occur 6 to 8. So the research is there. There are narratives of how this occurs. So going in, we are showing the steps between the standards, the focus of the day-to-day learning, those chunks. How do we get there? Where are we going? What are the building blocks to get there? What does it look like? How do you know? What's the criteria for success? This is planning that instruction. But I remind you that instruction and formative assessment are inseparable. And if we look at the definition of formative assessment, which we will in a bit, formative assessment is a planned process. Instruction is a planned process. And that's what we're doing now. We're planning the journey. We're mapping the journey. So to do that, I go back to my live binder under critical areas, and I look at the critical area progression for grade 4, critical area 2. And this is what comes up. Extend the understanding of fractious equivalence and ordering, build fractions from unit fraction, understand decimal notations. And what they have done, they have said, and by the way, this is not a rubric, but it is a progression. How do you get from here to here to here, here? It's a journey here. And so what we did, what they did under my guidance was take a look at what are the big ideas you see here. And so looking at those big ideas, because there is overlap, there's overlap here of talking about unit fractions, of comparing using a model, of using the symbols. There is an overlap here of knowing what addition and subtraction of whole numbers is and relating that to fractions, of understanding what multiplication and division is and relating that to fractions. Same thing with decimal notation. So what they did was they looked for those big chunks that they could see in being addressed in these 3 clusters. Sometimes we only have 1 cluster. Sometimes we have 2. Sometimes we have 4, but we look for those patterns. Then we went here because not only did the NCTM, along with Achieve the Core, identify the big ideas of critical areas, they also identified the cluster. So I went to Focus 2021, grade 4, and we looked at, here they are. Green priority, blue supporting, yellow additional. These are the clusters. But something else that they did this year in the summer was under Focus 2021, they went into the skills. What skills are essential? What skills can be eliminated? What skills can we spend less time on? And so going there and looking at our fractions, we noticed that under fractions, this is a critical area, and there were no skills that can be eliminated. There are, in other areas, if you look at this document, there are skills that it says eliminate. There are skills that it says reduce the time spent. And so they were helping us to do the decluttering. How do we declutter? Remember, standards are not a to-do list. The math practices are not a to-do list. That means they're not been there, done that, check it off, move on. They are for a purpose of building our understanding of the big ideas of mathematics. So after we did that, they were able then to come up with 5 big clusters that they thought they could address. So let's take a look at them. Remember, this was the goal of my unit. This was the prior knowledge. And so I can compare using visual models, 2 fractions, different denominators, numerators, using the symbols by comparing. I can extend my understanding of addition of whole numbers to show that a fraction A over B with greater than 1 is the sum of its fractional parts. I can extend my understanding of multiplication to show that A over B is a multiple. 2/3 is really 2 1/3 unit fractions. 3/4 is really 3 unit fractions, which are a fourth, and so on. I can express a fraction with the denominator 10 as an equivalent to the denominator of 100th and express them as decimal fractions, 1/10 or 10 100ths. And I can write them as decimal fractions. And then I can compare. Now, I like to call these lessons. Some people don't like that, but I'm okay with that. I call them lessons because under this lesson, I'm going to do several tasks, skills, develop skills. But in the end, my student must understand this to be able to go to the next step. It is a progression, and it progresses to here. So I'm going to do different tasks, different activities to make sure that I have confidence that my students can compare using visual models, 2 fractions, in order to move on. However, because of what we're doing, this goes back all the way to what Vygotsky said. If I have some students who aren't quite here yet, I can continue to move on because of the nature of what I'm doing, and I can scaffold some of this learning into this. This whole idea of moving the learning forward when we use the progressions, it makes it possible. I wish that I could share with you some of the things that teachers have said after doing this, and were not believers in the beginning, but saw what an impact that it has on learning. Knowing that this is a target, a goal that I need to meet, what are the activities, the tasks, the skills that I need to build to move them on? Isn't that what formative assessment is? It's moving the learning forward. How do I move the learning forward? So keep it sufficiently lean so that you use it. The only building blocks are the ones where you're going to collect assessment evidence. What is needed to move to the next rock? So look at where we're at. This is what session 1 was about. How do I build? How do I map that journey? We're all familiar with UBD. We've done UBD a long time. What do? We take and we identify a goal, a target of the unit. Remember, The literature says children can reach any target if they know what it is. But too often in mathematics, the target is moving or unclear. I identify a target. I identify evidence of learning by using a lot of good brain dump questions. And then I identify prior knowledge to see if children have access to the learning. And then I plan the journey. I map out the journey, talking about the steps along the way, planning tasks and activities to ensure that every child is able to move forward. Because in our next session, determine what students know through formative assessment using rich tasks instead of the typical pre-testing and post-testing we do. And then how to support teachers in using the teaching practices. So let's go back. When I'm planning my instruction, I am planning formative assessment. It is a planned, continuous process. Every question you ask a child is a formative assessment. Everything you do in the classroom should be a formative assessment. You're trying to assess where children are on this journey. We use it to reveal their learning, to analyze their learning, and to adjust my instruction and different strategies so that all children can achieve the intended outcomes. It's about equity, opportunity for all children to succeed. Let's go back to that formative assessment process. So with each of these learning targets, with my unit, I've done it, I've clarified the target. I know what it looks like to be successful. Then I gave a task to elicit evidence of learning. I interpreted that evidence, I identified gaps, and I planned for instructional adjustments. Scaffolding new learning if children didn't quite get it, because that's the beauty of the progressions, and I move all students to the next level. Now, I do the same thing with each of those progression targets. That summative assessment was to see, was the goal met? That's my assessment of learning. However, in this journey that we take, I do the same thing. I identify the goal. I know what it looks like when they get it. And then I plan activities to try to make sure that they reach the intended goal so that they can move to the next one, to the next one, to reach the ultimate goal of the unit, which is I can use my understanding of equivalent and decimal fractions to solve problems. So the question is, once we have this part, the mapping done, we know what the journey looks like. Then it is, what kinds of tasks will I give here? What kinds of activities will we do to ensure that they are well on their way on this journey? Formative assessment, instruction has to be well planned. It's just not a list of activities. It's not a list of things you're going to do or projects you're going to do. How does it help me to achieve that goal? Because each one of these, this provides access here, which provides access here, here, here. All of the literature that we have on how children develop these understandings, we need to take into account. We're trying to declutter our curriculum by focusing on those critical areas, by focusing on those chunks, those learning progressions that are so important to get us to that intended outcome. And so doing that is, go back to my analogy of the river. As we're going across the river, there's lots of stones. Which of these stones will enable me to get to where I'm going to be? What we know from all of our studies is that too often we have kids stepping on stones all over the place, and there's not a clear pathway. to get to the other side. This whole thing is about how do we help children to learn to learn? What does it mean to learn? But how do you get there if you don't know where you're going? How do you get there if you don't have a clear path? How do you move learning forward? How do you do formative assessment if you don't know what the next step is? How do you give feedback if you don't know the pathway? And so this is why all of this focus last summer and in the fall has been on declutter your curriculum. Ensure that you're focused on those critical areas of your grade level, your course. Once you have those critical areas, know what the prior knowledge is to ensure that all students have access to the new learning. And then as we map out the journey, what are those steps along the way that's going to move it forward? We know from studies that the single most common barrier to sound classroom assessment and also student learning is the lack of vision of appropriate achievement targets within the subjects they are supposed to teach. The standards are not a to-do list. The standards were for one purpose only, to help us to build coherent mathematics units around the big ideas of the discipline. Ideas are divided into clusters or groups of similar skills. Standards are skills. They are not a checklist. They are skills that are needed in order to achieve a bigger target. So if you think of it this way, it's about moving that learning forward. When we stop and we think about mathematics learning, and we go back to the definition of what is mathematics, it's a way of describing phenomena. What is it that mathematicians do? Mathematicians encounter a phenomena, a problem. They look for patterns. They make generalizations. They create models to solve the problems. I share this story because for me it was so powerful. I was in a first grade classroom a couple of years ago, and when I walked into the classroom, the first grade teacher had written on her screen, 3 + 4 = 7. And the warm-up was, write the story. Write this story of this number sentence. What story does this represent? 18 students in the classroom, 18 students wrote a story. Beautiful stories. 3 ducks were in a pond, 4 more ducks came. Now there are 7. It was simple, but really nice stories. Same day, 3 hours later, I'm in a middle school classroom. I sat down beside a young man, and the teacher gave them a list of 10 equations. First one, never forget it, 2x + 3 = 11. And the young man sat there and he tapped his pencil up and down. And finally I leaned over to him and I said, what are you trying to do? And he said, find x. And I said to him, and I pointed to the equation, can you tell me the story this represents? And he looked at me like I came from outer space and he said, Miss, this is a math class and we've got to find x. How sad that he did not know that was simply a model for some phenomena. What was it? You have 2 cups that has the same number of marbles. Mother gives me 3 more. Now I have 11. How many were in each cup? I mean, if you stop and you think about it, those number sentences are a model. They tell a story. What's a story? The chart tells a story. A number bond tells a story. A part whole tells a story. A graph tells a story. It does not matter. It's a model that represents a phenomenon. That's the essence of mathematics. So I cannot parcel out the content standards, nor can I parcel out the practices. Why? There is some essential content that I want my students to know and understand. I use that content then to solve problems and to construct a viable argument of why my solution is correct. We will never get there if all we do is we teach a topic without having any of those connections, knowing those connections between those standards to get to that cluster that gets to that critical idea. That's the essence of mathematics. So the life binders are there to help us with these resources of being able to find what are my critical areas? What does the literature say about how I develop those critical areas at my grade level? And then what kinds of tasks do I give my students to do? Do we really do tasks that enrich problem-solving skills that are authentic? Because remember, the standards came about to address functional literacy. Think about that for a minute. The reason for the standards was to address the issue of functional literacy, which today we call disciplinary literacy. But when the standards came out, if you go back years ago, literacy was defined in the 40s, 50s, 60s, up until the 70s, until the UNESCO defined literacy, was defined as how many years you completed school. If you completed 4 years, 8 years, it determined literacy. Then in the late 70s, UNESCO defined functional literacy, which said there's more to understanding numbers than just being able to count and add, subtract, multiply, and divide. You got to be able to apply it in your situation, in your community, as it said. And so realizing that we were continually teaching a lot of arithmetic, but not giving anyone a chance to really apply it, this is why we have standards. It's why in 2010 we redid them, because we used to call them processes and we didn't pay attention. And then in 2010, the new standards, we call them practices, the habits of mind of a mathematically proficient or literate student. And we call them practices because when we practice something, it becomes a habit. So the word from processes to habits. Planning the journey is so critical, and we don't spend enough time on doing that. This helps us to do better with helping students to achieve the goals of the target. I want to thank you for your attention, and I apologize for my error, but I will be with you live on the rest of the sessions, and they will be much more interactive, and I do hope that you bring your questions, and we'll be sharing some of the things that you're doing. So again, I thank you for your attention, and I thank you so much for allowing me to do this, and I wish you lots of luck. You will get a copy of the PowerPoint as well as the recording. So All the best. Thank you.